Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with episode number 250 of Ask Dave. This is a reference station video. The part we'll be discussing today is a reference design for a mast. And it's 20 feet high, and it's something you can attach a wire antenna to. You'll need two if you're going to hold up a dipole, or just one if you're going to put up something like an inverted V or put a cobweb up or something. It's not strong enough for something like a hex beam, so don't use it for that. Now, let's talk a little bit about what I mean by reference design. I'm going to give you a reference design down to and including the part numbers for all of the pieces that you need to assemble to put this thing together. Every single item that is listed here is available to you at Home Depot. Now, some of you may have a Lowe's near you or some other building supply store, so prices will be a little different, but they should have basically the same items if you choose to duplicate this design exactly. Now, the point of a reference design is that it can be a point of departure for something that you want to do a little differently, or something that happens to meet your needs better. Now, on this particular mast, it's 20 feet high. If you have parts of this already, you can reduce the cost. Perhaps you can make it for nothing out of stuff that you've already got around. Okay, so let's delve into the reference design and see just what it is. This is Ask Dave number 250 in a reference station design series. Part of the reference design that we've already put together is we've selected a ICOM IC7300, and we've selected a Samlex SEC1235M power supply. We started to pick an antenna but decided to go with a different one. So this is for a mast. Now, who is this really for? Well, this is for a new general or somebody who's getting back into ham radio, or somebody went all the way to extra on their first testing or something like that. This same mast could be used to put up a J-pole or a small VHF or UHF beam. Okay, so it could be used either way. It is a reference design for 20-foot high freestanding antenna mast, primarily designed for wire antennas. To again describe what a reference mast design is, we want to solve a given problem here. Now, the given problem is, in this case, hold up the end of a wire antenna, or hold up the middle of an inverted V. Sounds so simple, doesn't it? We're going to do something that's 20 feet tall because that's an easy height. It is lower than the optimum height for anything under about 26 megahertz, but I've used it on 7 megahertz or 40 meters, and it's worked very well. Okay, and we're going to use totally off-the-shelf components. The only tools that you will need will be a sledgehammer to pound in stakes and a 5/16 wrench or nut driver to, or a screwdriver to screw on the hose clamps. Now, this is critical. You can duplicate the design exactly, or you can adapt any amount that helps better fit your situation. Okay, this design assumes you have nothing high enough to attach wire antennas to. Of course, you have buildings, trees, you may have some poles or a tower or something, and you can use those. And in this design, you can substitute things that you already have on hand. If you have nothing tall in your yard, if you're out in the desert, whatever, and you really don't know what to do, this will work. It will work. Now, if you need to hold up more weight, like a hex beam, this is not the right design for you. I'm looking at wire antennas, things like a cobweb or a J-pole or a 2-meter beam or something like that. Let's take a look. This is an overview of the reference design. It's built on your local terrain. Okay, and it is a pole with rope, guys, and stakes, and I've got some little safety caps on the stakes here. and a pulley at the top here so that you've got a loop of rope. And if you've got a knot right here, you can pull down here and get it as tight as you want, and use a little hose clamp right here to clamp the rope to the mast and to keep it taut, so you can put up your rope leader and antenna, which are not part of the reference design for the mast. Okay, and this is 2 chain link fence top rails, 2 pieces end to end. Now, one thing I've not put in here, you're going to need something to keep the pole from sinking into the ground. You can put a brick under here, you know, a little step or a piece of wood or something. I haven't included that in the design. I'm assuming you're going to have something around that you can put under the antenna to keep it from sinking into the ground. What I have done, this is 20 feet tall, and we put the stakes out 20 feet apart. Now, this other stake over here, this angle here is 120 degrees, okay? And that's important because this other one will be out here. We're going to have 3 guys. Now, you may ask, where should I put the guys so that the thing is strongest for the antenna? And the answer, and I won't go through the math, but the answer is it doesn't matter. Put them wherever is convenient for you, okay? This mast is about 20 feet away. This one's also 20 feet away. If you want to turn it up to a fence that's kind of over here, you can save a few feet by putting these 2 out, and then this one will be in the direction of the antenna, okay? These are steel stakes, the safety cap for them. You could substitute rebar if you wanted to, something very, very strong and sturdy. This is strong rope, and so on. So let's go on to the parts list. Okay, here's the parts list for all new parts, if you want all new parts. 2 sections of chain link fence top rail. Okay, 2 100-foot hanks of rope, 3 2-foot steel stakes, 3 safety caps for the steel stakes, 3 2-inch or 3-inch hose clamps, I specified 3-inch, and a pulley. Okay, that's all you need. Okay, the mast itself is 2 lengths of chain link fence top rail. They're about 10 feet with a little 6-inch extension up here at the top that fits into the next one. So the mast consists of 2 sections of aluminum fence top rail. One section fits onto another. The source, Home Depot, here is the actual SKU. You only really need to use the last 6 digits of that. The cost for 2 of them, $27.94. Now, I want to point out that if you go online to the major ham radio vendors to buy a mast, all you are getting is the mast. This part right here. You're not getting the guys, you're not getting the stakes, you're not getting all that. So compare the mast price, whatever it is, to this price, $27.94, which will get you 20 feet in the air. Now, you could easily ask the question, why not 3 sections? The answer is it gets a little wobbly, and you're going to have to do a bunch of extra guying if you do that. And I tried it once and decided it just wasn't secure enough to even try. So I've stayed with 20 feet for these things. This is what the top of it looks like. This is a Home Depot picture. This part right here is about 6 inches, and it will slide into the next in the series. Here is how you slide it in. The 3-step photo here. You take this slightly squeezed piece and it goes in to the next one there, and then finally you get them together like that. Now, I would suggest you put some duct tape around here, okay? That will keep the thing together so it doesn't come apart on you as you're trying to put the thing up. The duct tape does not add any strength. It just holds the 2 parts together so you can get it up. Note that it doesn't really matter which end is up and which end is down, but usually I use this as the bottom part and this as the top. Now I want you to note that that can bend right there, that little 6-inch section. This happened to me when a deer got it. The thing ended up standing up kind of like this. It still stood up, but I did have to replace this bottom part to get my antenna all the way up. The antenna did not come completely down. Now let's talk about rope. This rope is a 3/8 inch. It's got a working limit of 244 pounds. This is going to hold that antenna in the air. You can really crank down on the tightness of your wire antenna with stuff like this, because it's pretty doggone strong. You're going to need about 130 to 140 feet of rope for the antenna, so you're going to need to buy 2. Now, if you're going to make 2 masts, you can just buy 3, and that will give you enough rope so you can save a little bit on the second mast. But $25.96 for the 2, and the SKU is right here, 706036. Now, here are 2 tips from the Home Depot website on how to handle this rope, because when you cut it, it's going to want to unravel. They call this rope fusing, where you just hold a flame. I used our gas range to do this, or stove. Or you can do what's called rope whipping, and it shows the steps here for doing that so that this will hold the thing together. Either way you do it, make sure that the end of the rope that you're using for the pulley is small enough to fit through the pulley. For other uses on this, like for guys, it doesn't matter. Now, speaking of stakes, these are 2-foot long stakes. And you say, I've never seen that at Home Depot before. Well, you got to know where to look, okay? This is the SKU 545259. These are not available online. So you can't go online and buy them in advance and go down and pick them up. You'll have to go to where they're kept. You can buy them at 2 feet, 3 feet, 4 feet. You can buy other types of stakes and so on. The cost for 3 of these is $13.41. You will likely have to ask where they are and have a assistant or one of the employees take you right to them, because the area where they are kept is not very big, and it's real easy to walk right by them. These are extremely sturdy, and you will need to pound them into the ground with a sledgehammer, not an ordinary hammer. Not a rock, not a piece of concrete, but a sledgehammer. If you don't have a sledgehammer, of course you could get one, or you could borrow one. The cost of the tools is not included here. Note that there are little holes here in the stake. Now, what I do with mine is I'll put a nail through this top one here and bend it slightly so that it can't come out. And then if I tie the rope under here, it can't get past that and come off. Also, this is a nasty little safety hazard out there, so we're going to talk about what to do about that. This is a steel reinforced rebar cap right here. The SKU number is right here, 438348. Okay, these slip over the top of the rebar and are left in place so that if somebody falls against this, they fall against this flat top rather than that end of the rebar. This could protect eyes and other parts. A bad fall on this might crack a rib, but if you fall on just the stake, it could actually penetrate. So safety, safety, safety. Note that you may want to wire this down to the stake so that, you know, the neighborhood kids don't pull them off or something like that. In our area, we don't have any children, so I don't use these, but I put them in here as part of the reference design so that you can use it. This is what happens. You push it down on the stake. This is the stake right here. Now put the cap on after you have pounded the stake into place. Don't put the cap on and then pound on the cap. press it into place as far as it will go. Now let's talk about hose clamps. These are just useful for everything. This is the one I've specified right here. They're a little bit big, but they do work. And of course, you can clamp them down as much as you want. This SKU 602048 happens to be for a bag of 10. So you can use these 3 of them. You'll need 3 of them for each mast. So if you buy a bag of 10, you save a little bit in bulk, and of course they're always handy for just about anything. To tighten the hose clamps, this is what you want to use right here if you can, a nut driver. This is a 5/16 nut driver. You can also use a 5/16 socket or just a 5/16 wrench. A sturdy flat bladed screwdriver will also work on this. The problem I've had with this is, I guess I'm just uncoordinated. The screwdriver keeps slipping out of this. So, and if I'm holding on to this with one hand and screwing with the other, it's a real easy way to poke a hole in my hand. Note that the hose clamp can be completely unthreaded. If you need to slip it around the mast where the rope comes down, you can do that. Push this end right into here, and while pushing it in, screw on this in a clockwise direction, and it will catch that and start to screw it around like that. Now we are going to need a pulley. The one that I've referenced here, 367184, will take this 3/8 inch rope, and you can thread it right through there and make the loop that you're going to need. So you can, once you have the mast up, you've got this ropes and a pulley, so you can just pull up the end of the antenna with that. It's a 2-inch pulley. It will support up to 125 pounds, which is way more than enough to hold up a rope antenna, okay? Now, if you're going to put up something like the cobweb or a J-pole or something like that, you won't need the pulley. But this is here on the assumption that it's a wire antenna. It's nickel plated, so when you put the hose clamps and stuff like that, you could get a little bit of corrosion, but I'm going to do this with a rope attached through here, and then the hose clamps to clamp that to the pole. This shows the very top of the pole. We're going to attach 1, 2, and underneath it is the 3rd guy rope, okay? Now I put a little bit of Scotch tape here to hold these in place so they're kind of uniformly around the pole before I put the hose clamp and tighten the bejeebers out of the hose clamp. Okay, these won't come out. These then go out to the stakes, which you've already put into place. If this is the center of the antenna, you've got 120 degrees out to one, 120 over there, and 120 out there. These are all designed to be 20 feet away from the center of the mast. We're looking down on the top of it right here. Okay, and then you will tie these to the stakes. You could use hose clamps. You probably want to use smaller hose clamps to tie this to the stake, but I found that just tying them will do. Note that if the antenna mast is not quite straight, you can kind of walk around the bottom of it just a little bit until you get it straight, and make sure it's put on something so it won't sink into the ground, especially if the ground is wet. Okay, this is a close-up of the pulley. It's right here. We've got the hose clamp around there to hold this piece of rope. Don't make this loop too long. You don't want the pulley to be able to twist on you. And then you'll put the rope through the pulley there, okay? Just make it short. That way the pulley will kind of stay put as you run the rope up and down through that. So again, to look at the reference design, we've got the 2 pieces of chain link fence top rail. Okay, that pulley at the top, we've taken about a 35-foot length rope, looped it through the pulley, and tied a knot in it. Now, that knot obviously can go down and up. When we bring the thing all the way up to where we've got our antenna tight, we put a hose clamp here and tighten that in place to hold the loop taut. Again, remember, something to keep it from sinking into the ground. And I laid out on the previous slide. You can go ahead, if you measure carefully, and put the stakes in before you put this up. And then if you pre-cut your rope to 31 feet lengths, 3 of them, you've got long enough guys to reach all the stakes. No discussion of antennas would be complete without talking about safety. Don't try to erect the mast alone. At a minimum, you need somebody to hold up the mast while you attach the guy ropes to the stakes. You should also have another person, a safety observer, whose sole job is to call 911 if something goes badly wrong. Okay? This will take a while to assemble. This is not a 15-minute assembly. It's 2 or 3 hours. Okay? Do use those safety caps if the children or the public will be around those stakes. Do tape down the ends of the hose clamps. They're strong and sharp. You may not need to tape the ones that are at the top of the mast, but certainly down where you clamp the rope to the mast to hold it taut. This is for wire antennas. Don't put anything heavier in top like a hex beam. I do have a hex beam. I did something very similar to this, but I used something very different from the mast. This is probably okay for a cobweb. Note that this rope will gradually aid in sunlight. Check every few months to make sure you're in good shape. It's not intended to be a permanent mast. Think of it as a medium-term portable. Now, you will eventually move on to other antennas, okay? So you'll end up taking this thing down and maybe reusing it, maybe changing the rope out, maybe putting it somewhere else. And of course, the usual, do not erect near power lines. Be wise, look around you. Take a moment before you start to talk to your observers and so on and your helpers. Say, okay, this is what we're going to do. Walk through the whole process. Here are any dangers like stakes and things like that, tripping over ropes and so on. So finally, let's look at the parts cost for one mast. This is one mast, okay? If you buy all new, if you don't have any of this that you can use alone, we're talking about, I'm assuming 8% tax wherever you are. Tax varies widely across the country. Some states don't even have sales tax. But a little over $100 to put up one of these. Again, I point out, if you purchase a mast, this is the part that you're buying, right here, okay? So if they charge $100 for that, don't forget you've still got to have guys, you've got to have something to attach them to the ground, you may have safety things you need to put on, you're going to need the hose clamps, you're going to need the pulley, all on and so forth, but about $100. Now, for your second ramp, you already have bought 2 lengths of rope. You only need to buy 1 more. And you've already bought 10 hose clamps, and you only used 3, so you've got another 7 to go right in here. Okay, so one of the things we learned from this is it can be the cost of the little extra part that can be the gotcha in terms of cost. Things like hose clamps and safety things and so on, rope and so on. You may have a lot of this already at home. You may have all of it at home, in which case you can put this thing up fairly cheaply. Okay, so this is a reference design. It's something you can duplicate exactly if you want and get a 20-foot mast that will hold up one end of a wire antenna or hold up the middle of an inverted V. Or if you have a building, say, and you put this thing out, you can hook the antenna between the building and the mast out there. It is pretty sturdy. I will tell you that. It's pretty sturdy. Won't hold up a hex beam. Hex beams, when you look at them up in the air, don't seem that big, but when you get them on the ground, they're big. Okay. Now, take a moment and subscribe, please. Click like. Go to dcasler.com/support for ways that you can support this channel. And next time, I'm going to do a video that's not part of the the reference design series, but it will be an Ask Dave video. We're going to look at the latest incarnation of the Micro BITX that comes out of India at hfsigs.com. The new kit, you can buy it with a case, and that's what I did. It took me about an hour to assemble it. We'll shorten that greatly when I'm going to talk about the Micro BITX in the next video. That's not part of the station reference design, but it is a cool thing that I just came across. Until we next meet, 73.